Okay, so now we are going to talk about vertex form. So vertex form looks like this. This is just like the normal equation, the standard one. It's y equals a, parentheses x minus h squared plus k, where hk is the vertex. On your exam for the network part of the exam, the crystal array network part of the exam, they show vertex form as y equals a, x plus b squared plus c. Just know that's the same thing, like very exact same formula. Looks a little different, but they're asking you to do the same thing when you see that, but I'm just gonna erase it for right now. So the very first thing we do when we try to graph something in vertex form is we find the vertex. So the vertex is the x value. So vertex is h and k, and in this case, h equals -4 because it's just the opposite of what's in the parentheses. And then k equals -3. So the vertex then is -4, -3. So just remember that the x value of the vertex is the opposite sign of what's in the parentheses. So then I'm going to graph -4, -3. 1, 2, 3, 4, 1, 2, 3. That's right here. And this is where my vertex is. And then the axis of symmetry always goes through our vertex. So the axis of symmetry is going to be x equals -4. And then again, this is just where this splits our graph in half, where it's a mirror. So we have 1 point, but to accurately graph a quadratic, we need 3 points. And so the way that we found a point in the past is we just kind of plug it into the equation. So I'm going to use a point that is close to our vertex. So I'm going to plug in x equals -3 because that was close to the x value of our vertex, which is -4. And I'm just going to plug that into this equation. So I'm going to do y equals -3 plus 4 squared minus 3. This equals 1 squared minus 3. 1 minus 3 equals -2. So our additional point is -3, -2. So that goes right here. And then because the axis of symmetry is a mirror, I know that my other point is going to be right here. Then I'll connect everything and I have this pretty quadratic. So that is our first example. If you need more time with that, go ahead and pause. But if not, we can move on. This next one is really similar. The only difference is that for this first one, our a value, like what was in front of the parentheses, was just a 1. This time our a value is going to be -2. So a equals -2. Our h value is 1 because it's the opposite of what's in the parentheses. So we see a -1 in the parentheses, so it's just the opposite. And then k equals 1. So I'm just going to put that over here. But that being said, that means our vertex is 1, 1. So that's what I'll put on my graph first. And that means our axis of symmetry is x equals 1 because it's just the x value of our vertex. So I'm doing pretty well so far. I have a lot of my graph done. And then I just need to pick a point and then mirror that point. So first I have to figure out what the point is. So I'll pick an x value and I'll pick x equals 0 just because that is close to x equals 1. And then I'll plug it in. So I'll get y equals -2, 0 minus 1 squared plus 1. Y equals -2, -1 squared plus 1. Y equals -2 times 1 plus 1, which is eventually -2 plus 1, y equals -1. So just a lot of like computation there. But that gives us the point 0, -1. We know based on plugging that into our equation that it's on our quadratic. So it'll be 0, -1 right here. And then I'll just mirror that and it'll be there. And then this is my quadratic. So I did it. If you have any more questions, just ask me, but go ahead and pause. And I think the Desmos activity will have some more practice problems coming up.